Hello everyone, welcome back to this last session of Microsoft Connect 2017. My name is Brian Randall. I'm a partner with MCW Technologies. I'm also a Microsoft MVP and an ALM Ranger. If you want to get a hold of me, tweet out to me at Brian Randall. Today I'm going to talk to you, knock on wood, about database DevOps for the .NET developer with SSDT and SQL Server 2017. So let's get right into it. Just a quick review, if you haven't got it in your head already, what we like to think DevOps is. DevOps is the union of people, process, and product to enable continuous delivery of value for our end users. Now, one of the things that happens when we start thinking about DevOps is a lot of times we focus as .NET developers on the application stack. So our web apps, our front-end code, mid-tier. But the database often is something that's shrouded in secrecy and managed in the back room. And what we really want to do today is show you how you can take your database and apply that same rigor and management of that important asset just like you do with your source code. So what we're going to do here today is talk about the process and the product on how you can do it. Just remember, at the end of the day, proper DevOps starts with you. It's an organizational transformation. Now, we think about the process. What we're going to go through here is traditionally think about an SQL Server database. It's on some central server. Hopefully it has someone who takes care of it, who loves it, cares and feeds for it. But often in doing that, we have a disconnect between how do we make changes that are necessary to deliver value to our users. When they ask for a new type of data entry form that requires data collection, or they want an extra data attribute added to the data model. So what we need to do here is have a process where we can apply version control, change tracking, and ultimately testing to deliver a high quality solution. So what we're going to do here is we're going to take the database catalog, that collection of assets, sometimes referred to as schema, offline. And we're going to put it under version control just like we do our C# code, VB.NET, F#, whatever language makes you happy. And we're going to track those changes using things like work item tracking so we know that it's going back to a customer demand. We're going to link it back to our product backlog item, our requirements, ultimately our users' wishes, because that's what we're doing. We're granting wishes. But then we're going to go that next step and say, you know what? I want to be able to take the changes I make as a developer offline to this definition of my database and have it go through a build process just like my code. None of that, it just works on my machine. It needs to work in production. We're then going to define a release pipeline. And we think about how we do those two things. Our ultimate goal, if possible, is to go with continuous integration, aka CI, and then go with continuous deployment, CD. And when we do all of that, we're going to run into one extra thing that's going on where we want to validate our changes. Because when we think about a database, it's a combination of that definition, the catalog, as well as the data. Now, when we think about what products we can use, well, on the client side, I'm going to use Visual Studio 2017, and I'm even going to use the Community Edition. With that edition, you can also install the SQL Server Data Tools, also known as SSDT. And that's going to give you the ability to work with your SQL Server database assets offline. On the server side, I'm going to use Visual Studio Team Services. If you happen to be working on premises with Team Foundation Server, you can do that as well. And this is going to give us work item tracking. I'm going to be using Get for version control. We're going to use the team build feature and ultimately release management. Now, when I do that today, I'm going to first primarily work with SQL databases in Azure. And this is going to represent my development, my test, and my production environments. But something amazing has happened at Microsoft. They've fallen in love with Linux. First, the Linux client and server running in Azure. And now this year, we have SQL Server 2017 that runs on Linux natively, as well as in a Docker container. And I'm going to show you that you can use the same techniques and tools used with SQL Server on premises or in Azure with your SQL Server databases running inside a Docker container. Now, when we think about working with SQL Server Data Tools, SSDT, what is this approach? Well, over the years, people have started thinking heavily about how can we apply this rigor to our databases. And SSDT has always taken this model approach where you go up to the server and figure out what is the truth about the definition. For a lot of us, we really only can guarantee that production is the truth. Any versions we may have zipped backups of or copies in development might not be the truth unless we have a complete pipeline. So what we're going to do is take the catalog offline and define a state model. And the state model is going to be basically the database entities represented as DDL definitions, which we'll represent in a serialized format as just .SQL files. Those files will be something that we can put under version control. But then what's really cool about the tools is we can then build our database project. And one of the options we have with building our database project is we can build what's called a DAC pack. That DAC pack then in turn can be used in conjunction with deployment tools like SQL Publish and SQL Package. And what we'll be able to do there is compare the definition that we have offline with any particular target. So if we walk up to an SQL Server database installation that doesn't have our database, it'll just create the new database from scratch. On the other hand, if it attempts to apply the change against an existing target, it will do a comparison between its state model and the model online. It will then look at the differences and apply those changes, assuming there's nothing that's going to cause data loss. If there's something, for example, like a narrowing conversion, or the need to do some kind of data motion, such as splitting a column, say first name and last name that are together into two columns, it'll by default block that. And you'll be responsible for figuring out how to do that in some kind of pre-processing task. Understand that while I'm going to use DAC packs, SSDT will help you do publishing right online directly from Visual Studio. But really, friends don't let friends right-click publish. So we're going to really try and do the CI/CD pipeline. And ultimately, if you have an environment where you can't really get to it for whatever reason, organizations sometimes have trouble getting on the DevOps pipeline, then what you can do is you can still produce scripts that you can provide to a DBA to run, God forbid, by hand. Now, that's it for slides right now with a couple summaries. We're going to switch over and do this end to end. So let's switch over to my dev machine here. And as I mentioned, I'm running Visual Studio 2017, and I'm connected to a team project I already created up in Visual Studio Team Services. I've called it Connect 2017, and I've got myself in here a couple times so that I can play the part of a manager and a developer. Now, as I mentioned before, we want to have traceability. At the end of the day, one of the successes of going fast with DevOps is reducing that lead time between when a user wants something and when they get it. And so when we think about compressing that lead time, we're trying to ultimately go faster. The problem is going fast without safety can be dangerous, hence why we're going to do things like apply automated testing. But ultimately, we always have to remember that we are human. As much as we try, it is statistically probable that you and I will make a mistake. And so when that mistake happens, what we want to be able to do is find out the source of the problem as quickly as possible. And when that source of the infection, the problem, comes from our application code or changes to the database, we ultimately want to get back to that as soon as possible. And that's why, even as a developer, we want to care about the fundamental notion of tracking our work. Now, I'm not going to give you a full project management lesson, but just remember that Visual Studio Team Services, as well as Team Foundation Server, provide rich work item tracking. And as you can see here, I have a simple PBI that says, as a customer, I want a demo. And this is assigned to my manager role. Okay, this is my product owner. And you can see we're committed to doing this. And then over here in the middle, I have a simple task. And what's going to happen here is I'm going to associate all my work with that task. And what will happen is, as I commit code, as I build it, and ultimately as I release it, I'll be able to see that traceability end to end through every step. Thus, if something does get into production and it causes a problem, I'll be able to quickly, surgically go back to where that problem was, make a correction, and get it out to my production system. Knock on wood, I won't have any failures today, and everything will be wonderful, and we'll go into the weekend. Okay, so there's our work items. Now, we're going to work with some databases. Now, as I mentioned, I have some up in Azure. And if we zoom in here, what we're going to do is we're going to start with my shared dev environment and ultimately my prod environment. And the idea is that I want to have a central place where my developers can work with a database, test both the database code, store procedures, functions, etc., as well as any application code on top of it. But if I don't have a well-known copy of the database definition offline already under version control, I'm going to need to do that first. So ultimately, I want to go to prod. Now, this is one of those opportunities, if you don't have a great relationship with your DBA, to do it here. Sit down together and do the steps I'm going to show you right now. So going back out here, you'll note, as I said, I've got my connection to Visual Studio Team Services here, to that same team project I showed you in the web browser. And now, what I'm going to do is come over here to prod, expand the link here, and expand my databases. Now, this prod database is sitting here, and I'm going to right-click on it, and I'm going to say Create New Project. Now, what I'm doing here is I'm walking up to the server, and I'm going to say, tell me all your secrets. Tell me all about your wonderful database objects. Now, the target project is asking for a name in case I want to redeploy from Visual Studio. It really doesn't matter what I put here, but for now, I'll just call this ADV Works LT Live. And this is using the AdventureWorks sample database, the light version. And then I have a local location of where it's going to create the solution for me. So out of my hard drive, I have a folder where I've already cloned the repo from up in Visual Studio Team Services. And so we're going to drop it right into there. So we're going to grab this path, paste that in there, and we'll even drop it into an SRC folder, tell it to create a directory for the solution, and add to source control. As you can see, there's other options here, but we'll just take the defaults and click Start. So what it's going to do is it's going to connect over the internet. Now I'm actually running this dev VM up in a private virtual network in Azure. And I've set up a trust relationship so that my machine can talk to the SQL Server database. By default, I wouldn't have it open to the worldwide internet. Not that I don't trust anybody, but you know. Okay, after a few seconds, you can see we're done. And when I hit Finish, what we'll see over here in Solution Explorer is I have a set of folders, and two of them represent the ANSI schemas that were defined within the database, DBO and Sales LT. And so if I come over here and expand Sales LT, we'll see I have some subfolders here. And within it, for example, I have a set of .SQL files that represent the definition for my various tables. Now what's great about the SSDT tools is over the years they've evolved. In the first version that was released back in the 2010s, around 2006, you only were able to work with raw TSQL files. But you'll note if I come over here and open up the product table, on the top half, I'm going to get the canonical rich designer experience you expect from Microsoft. A nice graphical view where I can define the definition for my table. However, down at the bottom, you'll see I've also got the TSQL. So that means you as a developer have the choice. Work with what's most comfortable. At the end of the day, the data is still going to be serialized back to a file format that's text, that can be easily differenced, and can be tracked in version control. All right, at this point then, I have the base definition of what I consider to be prod, my source of the truth, offline. So right away, I want to get this into version control. Now, if you recall, if we go back over here to my web browser, I have this work item here. So from the beginning, I'm going to start tracking the work I'm doing for this particular bit of work with that work item. Now I'm going to come over here and go to Team Explorer, and I'm going to select Changes. Because I'm using the Git integration, I'm going to type a commit message here. So I have my comment, and then I'm going to associate that work item. Okay, and that work item was 119, and then I'll click Add. And after a second, you'll see the title come up there, and I can see the information. And then I have my changes here, and I need to tell it that I want to stage all these changes. This allows me to control which files go into the commit and which ones don't. Now at this point, I'm ready to commit the changes to my local repo. So I'll say commit staged. Now, I'm the only person working here today, but I like to practice good Git hygiene. So before I send this up to the server, I'm going to come over here and select sync, and I'm going to do a fetch. Make sure no one's gotten into my repo and made changes that could affect my push. And look at that. I updated the README, so it looks like I do need to come in here and pull. Boy, you got to be careful. You never know who's going to sneak up on you. So now that I've done that, I now can push my changes up into Visual Studio Team Services. All right, So now I've got the code up there, and let's switch back over. And hopefully you've seen this, but this is one of the awesome things that we have in Visual Studio Team Services as well as Team Foundation Server on premises. And in fact, remember, 2018 just RTW'd this week on Wednesday. And you'll see I have my history, so I can see my changes. And if we come in here and start looking at the various bits of information, we can see all the files that I brought up. And you'll notice right here up at the top, we have this one work item, right? We've linked up and associated that commit with that work item, giving us that traceability. All right, well, at this point, I now want to get a build. If you've ever practiced continuous integration, you know it's important to get your builds going as soon as possible, the minute you start working with a particular solution, project, whatever. And so what we're going to do is come over here to the Build Hub, and we're going to create a new build definition. Now, one of the great things about the new build system that Microsoft introduced a couple years ago in Visual Studio Team Services and on TFS is that we've got a rich set of features for both building traditional Microsoft projects like .NET Desktop and ASP.NET, as well as a number of amazing vendor integrations from Jenkins to Maven to even Xamarin and Xcode down here at the bottom. Now, we don't have strictly a database project, but because SSDT projects live inside Visual Studio Solutions, we're just going to use the .NET Desktop one. That's going to serve us just fine. Now that I've done that, I have to adjust some settings. Now, the first thing I want to do is adjust this name here. And so we'll call this Connect 2017 ADV Works LT Live. And I need to tell it where to execute my build. Now, one of the great things you can see here is that we have a number of choices available to us up on the hosted environment. But I've also got my own private agent here that I built myself and put inside my environment. And the important thing here is that you can deploy from VSTS to a private environment in Azure like I have here, to a public environment, as well as to an environment within your firewall as long as the agent has access. And so that's what I've done here. So I'm set up a private queue, and then I'm going to drill down and find my SLN. There it is, and click OK. Now I've set these top-level process settings that will then flow through to the other tasks within my build. Now, normally when we have a project, say C#, maybe ASP.NET together, we hopefully have a unit test project, and that's something we want to run as part of the build process. But here's the fundamental issue. When we create the build, our output is the DAC pack. And the DAC pack itself isn't really testable. It's just an offline definition of the model. And so what we need to do is we need to get that model deployed into some runtime environment where it can be tested. And that's going to be an SQL Server instance. So now we're thinking about, we might need to run some kind of specific test related to databases. Exactly. So we're going to do that actually as part of the release process, not in the build process. So we're going to come over here and just get rid of this task in this case. Footnote, of course, within a solution, you could have your database project as well as a website project and any number of class libraries, for example. And so you might still want to keep that and just exclude the database test project, which we don't have yet if you didn't miss anything. All right, now at this point, the rest of this stuff is good to go. And at the end of the day, what's going to happen is it's going to take my output and make it available inside VSTS for the release management process. So we're going to take this information, and we're going to do a save in queue and say initial build definition. And this is one of the great things about using VSTS. When you edit and define your build definitions as well as release definitions, you get full versioning and traceability to know who changed it and why they did it. Now, as you can see here, it's kicked off a build. And based upon early behavior, this should only take a few seconds to run. And we'll just check a look. Any questions? Nope, not right now. Fantastic. And so we're going through, and we are done. So the nice thing when you have your private agent, it's all yours, and you can put some nice SSDs behind it. And so what we have here is the output of our build. And right now, you'll notice the build information here. And most notably, one of my favorite things, we have this information about what the developers did. And then if we go down a little further, there's our traceability. Right there, I have that work item that is what I linked during the commit and push. So at this point, when we look at the output, we can go, oh, this output came from this set of commits, and here's the justification for what the developer did. All right, over here there's no test results, and normally that would kind of bother me, but as I said, we're going to move our database tests over into our release process. Now, speaking of releases, how do we do that? Well, if you take a look here, you'll notice that there's a link right there. So we're going to click that Create Release option. And this is going to take us over to the release definition. And once again, we start looking at the amazing number of templates we have. A bunch of stuff for Azure, Kubernetes, Azure Virtual Machines, all sorts of great stuff. But this is one of those cases where we don't have something specific just to databases. But never fear, it's not that hard. So we're going to hit Empty Process to start. And we're going to change the environment name to Dev. And then we're going to come over here and take a look at the artifacts. What you'll see here is because I clicked that link from my build, it's picked the build as the input that's going to provide me access to that DAC pack. Now, the other thing you can see here is there's this lightning bolt that allows us to have continuous delivery. I'm going to turn that off for now because I'm not quite ready there. And remember, when you're on your DevOps journey, just because other people might be cranking along and doing something really fast, just remember, it's speed with quality and safety that you're looking for. Do it at your pace and do it right. Okay, so I've disabled that, and now if we take a look here, you'll see we have this environment. And the environment has one phase and no tasks because we start with something empty. Now, if we think about what we're going to do here, we need to take the output of the DAC pack, connect it with an SQL Server instance, and once again, this will support any number of different types. In this case, an SQL database in Azure. We're going to connect up to it, and we want to compare the copy of the model in the DAC pack to whatever target we pick and update the changes. So we're going to come over here and we're going to add a new task. And I'm going to come over here to the search box, which is really awesome. We just got so many tasks, it's hard to just scroll through. I'm going to type SQL. I'm going to click Azure SQL Database Deployment and click Add. Now at this point, you'll see I've got a bunch of items on the screen in red. It's telling me that you can't get through this unless you fill this information in. Now, a critical aspect, because my database is an SQL database in Azure, I need an Azure subscription and the appropriate permissions. This is something I already did in advance because it takes a couple seconds, and really, there should be a separation of concerns between your production, your dev environments, etc. For my demo, I'm using the same one. So I'm going to switch to Azure Resource Manager, and if I come over here and type MVPE in a second, it'll see my subscriptions. So we'll let this refresh. And there it is. Okay, showed up. Now, the next thing it needs to know is what is my Azure SQL Server name? So let's go back over to Visual Studio. And you'll recall I was working against prod, but I'm not ready to go to prod. So we're going to come over here to my dev environment. And you'll note that over here I've got the connection string kind of hiding out here. Now, you guys don't need to pay too close attention to this because I'm just going to grab it and copy it out. But we'll go a little further. That's good. We use everybody's favorite editor, Visual Notepad. You know, that's not really true. Most of us really like your friend and mine, Visual Studio Code. But for this little edit, this will do just fine. So come over here, get rid of the rest of this. And now we've got the DNS name for my dev database instance. We'll put that there. And now for the database name, once again, I can put anything I want here because if it's not there, the tooling is going to create it for me. However, I've already got a shared database called, you guessed it, shared dev. So we look in that list, there it is. So I'm going to call this shared dev. And it turns out I may have got this copied by getting a backup from production where they removed the customer data. I may have done it manually from some script files from the DBA, whatever. I don't know for sure until I run the copy I got from prod, my model, and push it against my database to know that I've got the same version. So even if the database was in there, we're going to get it synced up to the exact copy. Now the next thing I know is how do I connect? Well, there's a bunch of different ways you can do it. I'm going to use regular SQL Server security. And this is where we're going to look at my face for a second while I go out and get my password. Because no offense, I don't want to share it with all you guys out there. It took me a while to build all these demos. So show my smiling face. Yes, you don't want to see my password. Anybody there? Let's see. Okay. Is my face going out there, or is the computer? All right, well, you guys might get to see my password. Don't steal my data. Okay, hopefully you guys will be nice. Oops, Control Z. We don't want my password being out there for the rest of the world to see. So what are we going to do? Well, we're going to come over here, and there's this thing called variables. And for the variable, I can click add, and I can type password to DB, for example. And I can put the value here. Now we're going to go back to my face for a second so I can put the value in. And, well, once again, I might have to be quicker than them, and paste, hide. All right. Once I save the build definition or the release definition, anytime I use a secure variable, it will go away. So now that I've done that, password to DB is my variable. I go back to tasks, and then I use this syntax where I put $ password to DB, and I close it up that way. Now at this point, I have the password here. I got my SQL DACPack, and now I want the location of the DACPack file. So I'm going to come over here, and we're going to expand, go a little further, and almost there. There it is. So at this point, I've filled out all the information in the release definition that is necessary for the SQL task to connect to my instance and work with my database. So we're going to come over here, and we're going to save this release definition, initial release for dev. We're going to click OK. And if we come out here, then we'll see we have this new definition. I can come over here and create a release. First release to dev, and hit create. Now, you can watch this run. And what's, again, important about this is that we get that full traceability end to end from the commit to the build, and as you can see, to the work item. And if you come over here, if you have nothing better to do, you can go to the logs, watch it run. It's going to initialize the agent. Now, one of the things I did there is I actually picked the wrong agent. So it's quite possible that this could blow up or not work. But I'm going to fix that in just a second. We'll see how it does, though. It's downloading, executing. We'll see if everything decides to behave for me today. And almost there. And publishing database. Fingers crossed. Refresh. And it worked. Fantastic. So even though I picked the slower option and the hosted option, my release is complete. And we'll refresh that. And there we go. That's what I want to see, that happy green bar. Now at this point, my shared dev environment matches my production environment as far as the offline definition in the model and up on the server. Now the only thing that would be different here is that I would have to get sample data loaded. To do that, you can use post-deployment scripts if you have a small set, or I know with a lot of customers we worked with custom tooling that loads and restores the data that we want based upon how fast the changes are coming. So at this point, I have the ability to take my changes, track them in version control, run a build, and run a release, in this case to my dev environment. All right, so now at this point, we've got these two copies that are the same. But I want to make some changes for my users. So one of the things I might do is come in and add a new table. So we're going to come over here, back to Visual Studio. Oh, but before I do that, remember I unhappily set it up to run up on the hosted environment rather than my own. So let's come in here and change that environment. So we'll come back over here, go into the phase. And here you'll see it's using hosted 2017 by the default. We're going to change that to private. And we'll save that. Changed to private agent. Okay. At this point, we're good. We've got builds. and we got releases. So back in Visual Studio, we're going to close up the products table. And let's go over to our Solution Explorer. And let's just come over here and add a new table. One of the common questions I get is, Brian, how do I track changes and keep in sync a database with the application? How do I keep them working? How do I deploy them? One of the common things we do is we have some kind of version table that is stored in the database that is used to synchronize applications and the database so they know which version they're on. And typically we deploy database changes first, let them settle, and that means your application needs to be able to work with both the old version of the database as well as the new version. So we're going to come over here and just create a new database table, and we'll call this app version info. Click add, and you'll see it's already given us an ID field, and we'll just type version info. Doesn't have to be too fancy. Now I've saved the definition for this particular table. And as you can see, I now have a pending change here, right? I've got a little plus sign telling me there's an add. So going back over to Team Explorer, go home, go to changes, and we see the changes that have been made to the project file and to the .SQL file. So we're going to stage those, save, and now we'll say add new app version info table. We need to associate that work item, which was 119. And now I'll commit my staged work. Now that I've done that, I'm going to come over here. We'll do that synchronize again. We'll fetch. Hopefully no one's been messing around behind my back. There we go. And we're going to push. Now, once the push is done, right, we can go out there and run a build. And one of the big differences you'll notice between this build and the previous build is that the number of changes is going to be down to 1. And this means if we were to take that, then push it out and ultimately go to production, if something went wrong, we have this narrow location we have to look for the problem. It's very easy to find. Almost done, and there we go. So we go back to the build definition. We see the associated changes, in this case just 1. We see our related work item. And of course, these hot links take us there. And if we come over here to our release definitions, we can create the release, added new table, or whatever reason you want to put there. And now that release has been created, and the environment is set when created that it will kick off. So it's running in progress. We look at logs, and we can see it's executing now on the private agent. You can see that right there. Okay. And it's done. So at this point, I've been able to go add a new object, put it into the offline model, take my changes, put them to version control, run a build, run a release, and that means if we come over here and look at our shared database, expand out the tables, we can see our app version info table right there up in my shared dev environment. Okay? All right. Now, once again, going fast at speed means we need safety. And one of the ways developers practice safe coding is we use unit tests. This is something that a lot of people, I'm still surprised today, don't know is built into the product. In addition, there are third-party technologies out there that you can purchase, as well as there's open source projects like T-SQL-T and a new one out there called Slacker. And in both cases, these projects are ways that you can add additional layers of quality to your database by doing unit testing. What I'm going to do is going to show you the built-in stuff because it works against all the flavors of SQL Server, including SQL Database in Azure and SQL Server 2017 in Linux. So let's go back over here to Solution Explorer. And what I'm going to do is expand my functions. And we can see that I have this function called getAllCategories.sql. And what I basically want to do is make sure that whenever I change the database, that function continues to work. I really would want to do all of them, but we're going to take a baby step here. And fundamentally, if I have the right set of standard data that exists, if the test fails, it's going to fail for one or two reasons. My base set of data changed in some way that I wasn't prepared for, so we need to account for that. Or, more importantly, some changes made to the structure of the database that broke the function. And we'll be able to find that very quickly by having a test that can run on a regular basis. So I'm going to come over here and I'm going to right-click. Well, there's the function, by the way, in case you haven't seen it. I'm going to right-click and select Create Unit Tests. So let's do that. Now, as you can see, it will enumerate all of what it considers programmable objects in your database project. And I've only selected one. And then you'll notice something interesting here. It says, create a new Visual C# test project or Visual Basic test project. The reason is, behind the scenes, they use the standard Visual Studio test framework, MS Test 2 in this case, to run your unit tests. Okay? It actually wraps them around them and does all the core work. But you're going to write your test in TSQL, not in C#. So we'll call this ADV works LT live.unit tests. And we'll call this function tests. Okay. And we'll click OK. Now it's going to add a new project to my solution. And when it does that, it says, hey, we'll provide a way for you to run this in production, during a build, during a release, as well as the ability to run it from Visual Studio if you so choose. To do that, you have to tell it what you want your target database to be. Now, for developers, typically you're going to point this at a local private instance, just like you would with your unit test. You'd use local source data, and then your build would use some kind of shared environment, and same thing with your release. What we're going to do here is I'm just going to select my shared dev environment because I do have some sample data in there because I already loaded it before this talk. And so we'll come to select connection, and it'll look at my connections here on the list, and we're going to pick shared dev and click connect. We'll give it a second, and we'll click OK. Now, as I mentioned, you're not going to write your test in C#, so you might be wondering, why was I seeing a C# file there, Brian? Well, the reason is the default project has one in there to say, just in case you need to write some extra code tests. So we're going to come over here and just delete that one because we don't need it. And there's a little buglet that the team knows about that they're going to fix soon, that we need to get rid of this extra assembly that isn't needed anymore. All right, so we're going to save our changes. In fact, let's save the entire solution. Let's do a build. But now you see here I've got this basic test. Well, it turns out that function is just going through and combining some different input data and providing a nice list of categories. So we're going to come over here and get rid of these extra lines here because we don't need them. And that's our fundamental base test. Now the question is, how do you perform an assertion? Well, down at the bottom here, you'll see there's a number of conditions you can apply about what just happened. Was it inconclusive, which is the default? No, we know something's going to have occurred. In fact, we have a good idea we should get back some data. So if you look at this drop down here, you'll see there's a number of built-in assertions you can use. And what we look at here is say, well, not empty is a good one, but how about row count? Right, we're looking at static input data that's used as part of our application. So what we're going to do here is we're going to change that to row count, click the plus sign, and then over here in the property sheet, you can see that what we're going to do is we're going to set some conditions. So we'll call this row count, and this is categories. And then the row count from experience should be 37. Now we'll build this, and just like regular unit tests, I can run these from within Visual Studio. Go over here to the test menu, select Run All Tests. And right now I have one test, so we should see in a second in the Test Explorer that one test come up and it's passed successfully. So that's a good sign. But now we've got to think about, well, what happens if I take this unit test project and try and run it as part of a release? Well, in my example, it's going to run great because it's going to be able to run against my same shared environment. What happens when I have test and prod, etc.? Well, Probably don't want to run a test against prod, but you never know, depending on what the tests are. But the bottom line is, I don't want to hard code necessarily this particular connection string. What I really want to do is put some kind of token in there that I can use. So what I'm going to do here is, I'm going to quickly go over and grab something onto my clipboard. So let's leave the screen up. Leave me on the screen so I can copy this out. And we'll come over here. I'll put my face back up, please. There we go. Hopefully. We're going to grab this. And we'll close that out. And now we'll come back over here to Visual Studio. And you'll see there's this file called app.config. Now, one of the first things we want to do is we want to not compile that, but we want to always copy that out. So we're going to come over here and say there's no build action. But we're going to change this to copy always. Okay? And now we're going to come over here and we're going to replace the connection string with a token. And I'm using a library from another MVP named Colin Dabrowski. And so Colin's library looks for tokens with a double underscore in front of them. So we'll save that. And we're going to double check on that app.config, copy always. And we want to actually save that as content. Okay, looking good. Now, what we need to do is save this up to the server, just like the rest of it. So we got to go over here to Team Explorer again. Go over here to our changes. We're going to enter a commit message, add unit tests for functions, add our work item, and stage our changes. Okay, commit, same workflow. Go over to sync, fetch, shouldn't be any other changes, and we're going to push. Now, what's going to happen now is it's going to go up to the server. We need to run our build yet because I haven't turned on CI. Not sure we're ready for that. So we'll queue up another build. And we're cranking away. Almost there. And one of the reasons I'm doing this build first, before I do anything to the release, is that I need that output in there so I can set up the correct path to that app.config file. All right, now we're looking good. Let's go over to the release. Let's come over here and edit it. And now what we're going to do is go into that environment, and we're going to add two new tasks to the environment. The first one is replace tokens. And this is from Colin Dabrowski. It's available for free in the marketplace. And then I'm going to run the Visual Studio tests. So now we can go to replace tokens in app.config, find our file. So let's go over here and get the source path. There's the unit test, bin, release. There's app.config. We're going to grab that puppy dog. Now, it needs to know what it's looking for. So I need to add a variable. So I'm going to go over here to variables. Add connection string was the name I put in the source file. Paste that in. Come back over to my tasks. And now I'm going to grab this path here because it turns out that it's going to be relevant. And by the way, we don't put the file name. We just put the path to the folder. And then come over here to the test assemblies. We're going to tell it we only care about our unit test ones in this example. And we're going to tell it to search in that same folder where the app.config file is. So at this point, we're going to first deploy the database. And once again, if you need data in there, in between the execute and the replace tokens, you might have either a secondary task that puts some sample data in there if as necessary, or it can be done as a post processing script as part of the DAC pack. You can include all your standard lookup data there, for example. So now we've got those 3 tasks set up. I can save my changes. Click OK. And now we're going to click off this release, and we're looking for that added bonus that not only is it going to deploy the database changes, but we're going to run the unit tests. Hit create, open it up. There's our work item. Here's our logs. You can see now we got our new tasks that we're going to execute. See, it's cranking away. It's done the token replacement. Let's run our tests. And so we come over here, we see it succeeded. But here's the cool thing. We even see our tests show up in the list here. Change the outcome to all. And you'll see our unit test ran as part of a post-release step. This is going to give you more confidence to set up a full release pipeline. Now, I could go through and keep doing this all day long, but what does it look like if you set up a full pipeline? Well, I've got another team project that I set up. Basically, I'm going to pull a Julia child and go to the oven. And we're going to go over here to build and release. And we're going to go look at this release here, AdventureWorks LTCD. If we take a look at this, you'll see I've set up a similar pipeline as before with dev, but now I have test and prod. And notice that both dev and test have 3 steps. Execute the DAC pack, replace the tokens, and run unit tests. However, prod simply has the execute task. Now, my function test isn't destructive at this point, but I might have tests that are destructive, and I don't want to do that against production data. So we go back to the pipeline, but one of the things you'll see here is that I've got a pre-deployment condition. And this pre-deployment condition says that someone has to approve it. So this gives you that extra safety check to say, okay, did all the tests look good in our test environment? Is everybody ready to go? Yes. Click the button, and you're good to go. And to get email notifications if this happens. Now, I've been working with multiple databases up in Azure. But I mentioned that you could do this with a database running under Docker, under Linux, with SQL Server 2017. So let me get a connection here to my Docker container, or to my instance, sorry. We'll just connect with SSH. So I want to show you that I do, in fact, have it out there. So we'll go SSH vmadmin at ssdocker ubu from Ubuntu. We'll put my password, sudo docker minus, or p, sorry, I always forget the syntax, sorry, ps minus a. And sure enough, there you see I have SQL Server running in a Docker container. I've also been able to connect to that using the SQL Server Object Explorer inside Visual Studio. So you'll see there's Docker Ubu right there. And you'll see I have a database up there called devrm. This was a test I was doing. If we look at the tables and everything else in there, it's the same database. I was able to push it there. And to prove the point, if we come over here to my releases, you'll see that I have AdventureWorks Docker. If we go look at its definition, it looks eerily similar. Yes, that's right, folks. I'm able to connect to that same database using the same DAC pack technology from my build agent to a SQL Server instance running inside a Docker container on top of Ubuntu Linux. And that's the great thing for you as a .NET developer. You don't have to get too worked up about where the database lives. As long as you can set up a secure pathway between the build and release agent to your environment, you can use the SSDT tools and all the technology I've showed you today to have that great experience. And once again, we're going for that whole experience of traceability end to end between our builds, our releases, and our work items, which ultimately come back to delivering value to our users. So we can figure out I've done this at this point. So let's jump back to the slides. I'm not seeing any questions yet. I know it's Friday, so people are like, we'll watch this later. Some considerations you should have when working with SSDT, database projects, and SQL database instances. As I mentioned earlier, how do you update the database and app together? The consensus out there from a lot of people, if you're using the state model approach we're doing and really thinking about apps and databases together, is that you want your app to be smart enough to work with the current version and the new version. Databases often can be full of terabytes of data, and you might even want to settle that you made the change to the database, but things continue to work. There's no weird anomalies in the data. So we'll often update the database first. The application will continue working against this new version of the database, and then when you're ready, you just roll out the new version of the application on top of it. Other things you have to consider dealing with is drift. When we set things up, I said, I'm going to go to production and grab my source of the truth. I'm then going to create my offline model. What happens if someone makes a change in production and doesn't tell you? Well, the good news is with the tools we have here, the DAC pack will protect you from things because it can block if it doesn't know the information. In addition, you can use tools like schema compare to compare the source of the data, your definition model, etc. As well as different vendors have tools out there. Redgate has a great tool called DLM Dashboard that's free that you can use to monitor for drift. Other issues you'll run into is data motion. SSDT doesn't do data motion, which means if you have a narrowing conversion, if you have a split column, you're going to have to do the operations to take the data offline, move it around, and fix it up before you change the schema. Static data lookup data, if it's small enough, you can embed the DAC pack, or you can have a secondary loading. And once again, test data. In most situations, you should not be working with a copy of production data. There's all sorts of regulations for just about every industry out there, whether it's PAI, HIPAA, or any other information that generally should be floating around in a dev environment and definitely not on your dev laptop that could get stolen. So really have some good ideas about good data sets to give you consistent over time results. Well, at this point, I haven't seen any questions. Once again, not surprised, but hey, you can find me on Twitter at Brian Randall. Get yourself an Azure subscription, a free VSTS account, and try this all out. You can find me on Twitter at Brian Randall. Visit the Connect Channel 9 page to revisit all the great sessions we've had this week here at Connect. And you can continue your education on the Microsoft Virtual Academy. And hopefully early next year, I'll have a new course from LinkedIn Learning that covers database DevOps in a longer, in-depth environment where you can look at things on a longer level. So thanks very much for coming to this session, as well as Connect all week. Be good humans, happy holidays, and hopefully we'll see you next year. Bye-bye.